GM, and welcome to the Self Workshop. So my name is Remy, I'm co-founder and working at Self. And today we are going to see how you can integrate easily Self inside your application. So Self is an identity protocol which allows any application to verify the identity of their user extremely easily while keeping their information private and letting them stay anonymous. So to do so, we are using zero-knowledge proofs and biometric passports. You can know if your passport is a biometric one if there is this logo on it. So if that's the case, it means that your passport is already supported by the protocol, which is great. If not, we are currently working to extend the support to other ID documents, like the EUID card or the Aadhaar, which is a local solution from India. Anyway, if you don't have a biometric passport right now, that's not a big deal if you want to build on top of Self. Because I'm going to show you right after, but you can generate mock passport data from within the mobile application, which you can, of course, use only for debug reason. That's it. Cool. So the plan about today is first for me to give you more information about the project, what is the vision behind. Then we can talk about bounties because yes, we are sponsoring Taipei Hackathon. There is a bunch of bounties there. So after that, we can check together the documentation and finish by the most important, which is get our hands dirty and dive directly into the code. All right, so why Self? So let's say that you're an application that needs to verify the identity of your user online. Right now, you are probably going through the traditional KYC process, which is extremely painful. So I think that I did it something like 5 or 6 times in the previous months, and each time that there is a lot of friction, you need to find your ID document, take a picture of it, send it, and then you need to wait until the verification. So if you're an app, you're going to experience a lot of drop-off at this point, and unfortunately, there is nothing much that you can do. Like even that's not secure from your perspective, because using generative AI, now it's childish to generate mock images of passports. You can also do deepfakes extremely easily that are really convenient. From the user perspective, it's not secure too, because I'm going to basically take a lot of personal information and send them to third-party applications. And it's going to be stored on DB there that can be hacked. And this kind of hack happens all the time, actually. And you wake up 6 months after and you realize that someone contracted a loan using your identity. That's bad. Also, if you want to verify this identity on chain, that's not convenient. So yeah, and the cherry on top is most of the time sending all of this information is not needed. You only need to prove something that is really granular about yourself, that you're above a certain age, that you're not part of a list of countries or part of a specific countries, for example. But that's it. You don't need to share all of your information to a third-party application. So how can you solve all these issues at once? That's a good question. And to answer it, I think we should talk a bit about what is a biometric passport and why these documents are so cool. So inside this document, there is a RFID chip, which contains the digital signature of the passport, meaning that we can verify this signature inside the zero-knowledge proof. And by doing so, I can already attest, and that's exactly what I'm doing using Self, but by doing so, I can already attest that I own a valid passport, that on this passport, maybe I'm above a certain age, older than 18 years old, I don't know, without revealing anything else. And you can verify this proof on-chain easily because ZK proof are succinct. Also, you can't cheat with ZK, so to generate a ZKP, you need a you need the digital signature of a passport that had been signed by a real country. So even us who are managing the protocol, we can't even forge fake identities to Sybil attack a protocol that integrates itself, which is great. Like Sybil attack happen all the time on airdrops, for example. So Self is a really good production for that. So right now we are supporting passport, but the vision is way much bigger. We are aiming to support any identity documents that is signed by a country. Okay, so let's look at what is Self, like the mobile application. So from a developer perspective, using the Self SDK, you can generate a QR code and you can put parameter when you're going to develop to ask your user to disclose a particular information or just the fact that they are human because they own a valid passport. So this is the flow. The person is going to scan the QR code. On the phone is going to be prompted the different information that I will need to disclose. So as a user, that's great because it empowers me to notice each information that I'm going to share with the application. Yeah, and then I just generate the proof, and then the proof is verified. The first step is actually to scan the passports. The very first one is to scan it using your camera. It's not taking a picture, it's just reading some fields. Because the digital signature is inside the RFID chip, and this one is protected by a password, which is the birth date, expiry date, and the passport number. And these are present on the main page of the passport, so that's why you need to scan it first using the camera. So the step right after is scanning using the NFC reader of the phone, the RFID chip of the passport. So this one can be present on the back cover, on the front cover, or on a page at the middle of the passport if this one is plastified. A little tips for iOS user, the NFC reader is always at the top. So what I recommend to do is first try to scan the last page of your passports, always from the inside, because for example, the American passports is protected by a layer which prevents people from scanning the RFID chip from the outside of the passport. All right, so scan the passport, then that's what you're seeing on screen. So generate the ZK proof, I'll wait for verification, and then the proof is verified. And now you can scan the QR code and prove your identity. Or should I say, prove yourself. All right, what can you prove exactly to third-party applications? So there is the birth dates. For example, we run a small experiment during ETH Denver, during which if you were able to generate a proof that your birthday was during the week, you would be able to claim $100. And I think we should do the same for ETH Taipei. Then there is the expiry dates. So for this one could be interesting if you want to mint a token that attests that you own a valid passport until this expiry date. That's great. Name, surname, and passport number. So this one are pretty cool. I think we can get extremely creative with these. For example, the passport number during ETH San Francisco hackathon 2 weeks ago, a team built a project using which with Self you can send money to a passport number, and then using Self you can claim this money using the passport number. Meaning that I can send money to a friend because I know his passport number or he gave it to me. And even if he don't own an Ethereum address yet, he will be able to claim it in a second time once he gets onboarded. So that's great, and it's actually solving a real world issue. So I think that's like a really nice use case. The gender, so this one, I think we can get creative too. Older than is really interesting if you want to gatekeep contents or access to an application. So let's say for social network, if you want to buy alcohol online too, for example. But also if you want to gate access of your DApp to people that are above 21, that could be interesting. Nationality, being able to prove that you are not part of a country or country list and being able to prove that you are not part of the OFAC sanction list. So these are super interesting for compliance use cases. I would love to see them in real world application like DeFi protocol. All right, let's talk about bounties. So for ETH Taipei Hackathon, we have a total of 10K in bounties, split in two categories. The first one is if you verify the self proof on chain, and the protocol is based on Silo. So I hardly recommend you to double check the Silo prices because you could commit them. So the first prize is 3.5K. The second one is 2.5, and the third one is 1.5. And like it's going to be the best overall integrations. The second category is the off-chain integration. So the first price is 1.5 and the second price is 1K. So this seems a little bit less juicy in terms of prices, but if you're a beginner, that may be a good start to integrate the project. Because you are going to see, but verify the proof in the backend is extremely easy. Extremely easy. By the way, the prices may change in the next few days, so please double check on the official page of ETH Taipei. Great, let's check together now the documentation. You have access to the doc on docs.self.xyz, and we should look at the quick start. So the SDK is split in three parts. The first one is for the front end. The second one is for the backend. And the last one is for the smart contract. All right, so for the front end, there is this library, self XYZ/QR code, that you are going to import inside the front end of your web application. If you want to use self from another mobile application, I'm going to show you how you can do this right after, but you can still do just not using the self QR code SDK, but using the core SDK. What you are going to do if you want to do so is instead of generating a QR code that people are going to scan, you are going to generate a deep link, and you can just like have a button and user click on the button and it's going to open up the self application on the right page. Cool. So here you have like all the disclosure options that you can put, and you can see how you can use them inside the SDK. So I'm not going to linger on this because I think that the best is actually to learn by coding, and this is what we are going to do right after. So here is how you can render the QR codes, the different parameters and attributes for each of them. And this part is how you can integrate the self core SDK, which is used if you want to generate the deep link or if you want to verify the proof inside the backend. All right, and there is pretty much the same, but one more time, we're going to check, like we're going to code this directly. The second section is the SDK reference, and it's constituted by a description of the different classes, parameters, and everything of the function and everything that is inside the SDK. All right, the third one is really interesting. That's for the smart contract SDK. First, you have a basic integration. Then you have the airdrop example. If let's say that you want to integrate self to bring civil resistance to an airdrop, that's how you can do it. Then you have the happy birthday example. That's the one I was talking about before. I think that's a really good one if you want to verify proof on chain. That's a really good reference. So for this one, we were retrieving the birth date from the proof. But if you check utilize passport attributes documentation, you are going to see how you can use the other attributes like the passport number, the name, the issuing dates, like if the person is in the OFAC list or not, and so on. The last section is the technical documentation. So there is an overview. on which you can learn about biometric passports. So that's actually extremely interesting. Then there is the architecture of the protocol. We are not going to discuss about that today because we don't have the time, but definitely worth checking this. And the last one is interesting. These gather the address of the deployed contracts, and you will need some of them in the constructor of some smart contracts when you deploy them. So keep this one in mind. You'll need to use it. Great. So I think that next step is just for you to download the Self application. So go on the App Store. It's available on the App Store and for Android too, and look for Self ZK, and it should be the first one. All right. So the first page you are going to land on inside the Self application is this one. So if you own a valid passport, just click Get Started and follow the flow. And if not, this is where there is an Easter egg. You see these 3 cards. You can click them using 3 fingers 2 or 3 times. And by doing so, boom, you are going to land on this screen, which is the screen to generate mock passport data. So you can choose the states, the age, when the passport is going to expire, and if the passport is part of the offer list or not. So just click on Generate Passport, and then you can confirm your identity and register to the protocol. All right. The mock passport generation can take a bit of time on low-end devices because like a bunch of cryptographic operations are going to happen in the backgrounds, because basically you are going to create the same cryptographic objects as there is inside real biometric passport. The only difference is that it's not going to be signed by the real country, it's going to be signed by us. So that's why you can't use this in production. So personally, I'm going to use my real passport. So I scan it using the camera. Then the step after is scan the RFID chip. Then I'm landing on the same screen. I can confirm my identity and identity verified. So this step can take up to 1 minute, the identity verification. And why? Because countries are not using the same signature algorithm and hash function for the passport data. There is even other European countries such as Germany who's using like SHA-512 or SHA-224 with brand pool 512. So the proving time is going to be different according to which signature algorithm and hash function is using your country. So just be patient and wait, stay on the screen. All right, so now that you're onboarded, the next step is to clone the workshop repository. So it's available on Self XYZ organization on GitHub, and that's the workshop repo. So just clone it. That's a really simple Next.js application. So first step is, of course, install the dependencies. Personally, I'm using bun, so bun install, but it's going to work with npm and yarn too. And then you can just run bun run dev to run the local server. So to verify a proof using Self, you need to set up an endpoint and not like a public one. And for this, you want to put this one in the .env in this project. So what I do personally when I develop, I use ngrok. I invite you to check this one. It's really simple. It's just one command, ngrok http 3000, and then it's going to generate you a public endpoint that you can use. So once it's done, copy paste it inside the .env. Great. So let's check the frontend page. So in this one, you are going to import both Self QR codes and Self Core SDK. First, you are going to create a Self app, declare the app name. So This is the one that is going to be displayed once you scan the QR code inside the mobile application. You declare a scope. Think about the scope like an app ID. So you can use up to 24 ASCII char. So you can't put emojis for this one, just like traditional ASCII. But for the self app, you can put emoji or whatever you want. For the app name, sorry. Then you need to put the endpoint. So for this one, don't touch anything because we're inside the this repo. So everything is set up. Then there is the logo base64. So you can either dump the whole base64 or you can just put a link to a PNG. SVG are not allowed, so just make sure that it's a PNG. Then the user ID type. So if you are using a traditional UID, the user ID is how you can link the proof with the user ID inside your application. So if it's a Web2 app, you don't have to put anything. And if it's a Web3 one, you want to put a hex because it's not going to be a user ID like a UID. It's going to be an address. But yeah, in our case, we'll go with the UID. And then you can see the disclosure options. So for this one, let's get back to the doc.xyz. And if you go into the quick start, you will have here again all the disclosure options that you can have. And if here there is written like that for the countries you need the 3 letters alpha code, actually there is an object that you can import that will make your life easier. That is the countries from the core SDK. And then you will have like auto completion. So countries dot, I don't know, Algeria, for example. And last step is just to call the build function. So I can uncomment this one if I want to prove that I'm not part of the offer list. And finally, I can just scan the QR code. So this is how you can render the QR codes. You have an onSuccess function that is going to be called once the proof is verified. So in our case, we're going just to change the route. And then, so this is not part of the QR code. Yes, you have a deep link function. So please put the self app inside the self QR code wrapper. And I'm going to show you what is the deep link function. So this is a deep link QR code. You can see that it's quite complex because it's going to contain all the information about the application. So when I scan it, it's instant. It's like that because I enable the deep link type here. But if I don't do it, you can see that the QR code is going to be way much simpler. But there is a small lag when you scan it. It's because the app information are going to be sent through WebSocket to the mobile application. So if you are using the complex one, the deep link, please don't dump the whole base 64 unless it's going to explode. All right, so I invite you to modify the QR code, like modify the parameter. There is also I think that's a dark mode somewhere. Oh, not in the button. Should be here. You have a dark mode that you can set to true. And then it's going, like if your web page is in dark mode, you can just enable this. All right. I invite you to play around, modify the different parameters, scan using the QR codes, scan using the mobile application. You are going to see that if I scan this one, are going to be displayed here, all the information that this application requires me to disclose. All right, let's now check how you can verify the proof. So for that, we want to go into root.ts. So root.ts is follow the classic pattern for Next.js backend verification, like backend application. So once user generated the proof is going to be sent to the endpoints that you set up inside the .env. and it's going to be to trigger this post function. In the body of the requests is going to be there the proof and the public signals. And both of them needs to be verified to be sure that the proof is valid. So imports the self backend verifier from the core SDK. So in this part, we are just going to use self xyz/core because you don't wanna import the QR code one because there is like a React component and it's not compatible with Node server. Anyway, so instantiate this self backend verifier object. The first parameter is the RPC URL, so you can just use this one. Then there is the scope. Be sure to use the same scope as the one in the QR code. It's really important. If you don't, the proof won't be verified. Then there is the UUID, so this is the UUID type. And the last one is if you want to allow mock passports. So if you plan to use mock passport, set true. If not, don't put it. And personally, as I'm going to use my real passport, I'm not going to put it. And then you can just, on this object, call any function to enable some specific verification, like set minimum age. You can set it to like to 20 in this case. You can set the OFAC check like that. You can put the other countries like this. And yeah, that's it. Next step is to verify the proof. So you take the object that you just created and you are going to call the verify method. And in this method, you are going to pass, as I said before, the proof and the public signals. And this, calling this function is going to give you back a result of the verification. You can print this one if you're interested, but I guess that what you are the most interested in is this credential subject, because in this object, you are going to find back all the passport attributes that the user can disclose. And again, make sure that what you are going to use here is compatible, like is the same thing as the thing that you asked on the QR code part. Because if not, like the field is going to be empty. Like if I want to use the gender here, but I didn't ask the user to disclose the gender before, like this field is going to be empty and the gender is going to be null. So make sure both are the same. All right, so then there is the nullifier. What is a nullifier exactly? So when someone discloses its identity using self, he will be totally anonymous, meaning that in theory, he would be able to use, like to disclose many times and use many times the same identity, unless we introduce a nullifier, which is what we are obviously doing. So this nullifier is going to be the same for each person, like for each passport, according to the scope that you are putting. Meaning that for the scope self workshop, I'm going to have like one nullifier, and for another application that will have like a different scope, my nullifier is going to be different. So if you want to check this for CB resistance, just make sure, like you can start the nullifier in a DB and just make sure that that's the first time that you see the nullifier each time. And last thing is just call the isValid parameter of the result object, which is a boolean, and it's true if the proof had been verified and false if not. You want also to answer to the request, of course, and why? Because for the user experience, like the user inside the mobile application, he wants to know if the proof has been verified or not. So follow just this pattern to send back the response of the request. So if I'm a mobile application, I'm not going to display a QR code. What I want to do is the user to be able to switch from my app to the self app. And to do so, that's this little component. You want to use a deep link. So in that case, import the function get universal link from self XYZ core SDK and just pass the self object. So if you are developing a React Native application, you can do this directly. And if not, the deep links are pretty easy to generate. So reach us in case you want to do this directly on Swift or Kotlin or Java, but it should be easy to integrate too. I can show you what a deep link looks like. It looks like that. All right, so now let's scan the QR code and generate the proof. This one is actually way much faster than the other one. It's currently proving, and that's it. Proof verified. All right, let's switch now to smart contract verification. So now you can go to the other repo, which is the happy birthday one. So self XYZ on GitHub. So it's still in the same organization, and you can just clone this one. All right. So this repo is actually in 3 parts. There is the front end, we already know this, the backend, which is going to receive the proof, and the smart contracts that are going to verify the proof. So yeah, the only difference with the project before is, of course, there is a smart contract implementation, but on the backend side, instead of verifying the proof using the backend SDK, you are going to send the transaction on chain and verify the proof inside your own contract. So this is the main page. I don't think that makes sense to spend time on this. So yeah, this is the QR code. Let's check directly what's happening inside the backend. So in this one, we are going to receive the proof. So again, proof public signal inside the body. That's the same. We are going to grab the address. So the address is the user ID, as we saw before. And if you want the user to put an address instead of a UID, you just have to put the hex flag for the user ID type. All right, then you declare the contract address, you set up the provider, the signer, the contract. And here you can just call the contract and send this transaction with the verify self proof function. So we are going to see what this is exactly right after. And here you need to parse the proof. So I think we are going to create a bunch of helper functions for that, even if that's not complex, to avoid stupid mistakes. So check again the documentation, it should be updated by then. All right, to check the contract integration, you can go to happybirthday.sol, that's the one. And in this one, you see that we are using the self XYZ SDK, but the contracts one. So that's the one you need to import. So to verify a proof, a self proof on chain, you need your contract to inherit the self verification root class. So as our contract is also doing a bunch of stuff like sending money to someone, there is also the declaration of the ERC21, the claimable amounts, but it's not what we are going to spend time on. So this is the mapping of nullifier. That's extremely interesting. So remember, the nullifier is what makes an identity unique for a given application. So here we decided to store the nullifier, of course, because we are giving $100. We don't want the person to just spam us and just hold the wallet. Yeah, let's first check the constructor. So this is the one that is interesting. So when you're going to instantiate the self-verification on root class, you need to pass an identity verification hub address. So this is the contract that is really going to verify the proof. Then you need to put your scope, the attestation ID. So this one is one for passport. So for now, it's not super relevant, but in the future, when we're going to support a lot of identity documents, you will be able to cherry pick if you want to, if you want to like accept this document or this one or this other one. Anyway, then you are going to pass if you want the older than check to be enabled, and if so, what would be the value, and the same for the forbidden country list and for the OFAC check too. All right, so this is the function that we called from the TypeScript. You can see that the argument is a proof, like is this object, which is actually the one we know with the proof and the public signals. So the first check is to ensure. So what's happening here is exactly what's going to happen in the TypeScript when you run the backend verifier. But here, to have more flexibility in the contracts, we want to do part of the implementation ourselves. So the first check is going to be the scope. You want to make sure that this proof is destined for your smart contract, your application, and your application only. So if this is not the one that you settled before, you're going to revert. Same for the attestation ID. So this is the nullifier check. So if the nullifier is already present, so to get the like the nullifier from the public signals, you can just open the proof objects, and inside there is public signals, and then for the index you can use this object, which is going to give you the index of each public signals. Like any passport attributes is going to be there in the public signals. So if the nullifier is already in the mapping, you are going to revert. And then you are going to call the hub to verify the proof. So when you call the hub, you need to pass several arguments, the one that you settled inside the constructor. So if you enable older than check, and if so the value, and so on. And the last one is the proof. All right. And then what we do here is we call this function to check if the birthday was in the window, like the 7-day window. First, we set the nullifier to true, of course. And then, oh yeah, first, let's go to this function. So you got this parameter. So inside the results, you have a parameter that is reveal data packed, and this one corresponds to the first data group of the passport. So as like in order to save gas costs, we are going to pack this signal. So you need to unpack it to cast it to something that is human readable and that you can interact with in the smart contract. So for this, we already have a bunch of helper functions like the formatter library. So you can just use this to get the char codes. Then if you want the date of birth from these passports attributes, you can just call this new circuit attribute handler class with the get date of birth function. So we'll have one function for each attribute. We can check this in the doc right after. And then what we did is once we have this date of birth, so this is in ASCII, we want to cast it into number. Like we want from this ASCII to check with the current timestamp using block.timestamp and just check if we are in the range. And that's it. So getting back to the doc, we are going to see how we can use the other attributes. So the function that was called inside the happy birthday example, it was the gates date of birth. And here you will have like all the other one that you can use. So this is the one that we use, but there is one for the gender, for the expiry date, for the older than, um, one for the name too. So this is how you want to interact. Yeah, this is how you want to interact with the different passport attributes. There is another function to get the forbidden country list, because it's not in the same signal like public inputs than the passport attributes, but you can, yeah, just check the doc for that. So what is interesting to know is all the attributes, they are going to be given back as key values. So each time you want to perform operation with them, you need to cast them back to uint. So as you can see, nothing too complex on the smart contract side neither. The only main difference with the backend verification is that here we are going to retrieve the different passport attributes from the proof and perform the equality check yourself. The main advice that I have is just be careful about the ASCII casting. But I think we're done. So I guess you are ready to start hacking on Self. I hope you enjoyed this workshop. On the left here, you will have a QR code to the main repo of Self. Everything is open source, so don't hesitate to start the repo. And on the right, you have a QR code that will link to the main websites, self.xyz, and from there you will have another link to the GitHub, to the documentation, and there is not on Self, which is blog posts that we are going to create more. So don't hesitate to read some. We just run an audit with ZK Security, and a bunch of stuff are going to come here. All right, thanks for your time, and see you.